Hello everyone and welcome back to my channel. We're going to be talking about inverse trig derivatives, so don't forget before we get started to like, subscribe, and hit that notification bell. We're going to be talking about right triangle trig, so let's talk about right triangle trig. The first thing we got here is we need a right triangle. The other thing we always need is we need a specific angle to look at. So when we are looking at our triangle, we need to kind of be able to name these different sides. So opposite, adjacent, and hypotenuse are going to be really important. So adjacent is always the one that's touching the angle that we're looking at and the 90-degree angle. The hypotenuse is always the side across from the 90-degree angle, and opposite is always the side opposite from the angle that we're looking at that's not the 90-degree angle. So some things that we want to know and remind ourselves about is things like SOHCAHTOA, SOHCAHTOA, and specifically I like writing it like this because it's saying sine opposite divided by hypotenuse. It just makes it a little bit easier to kind of look at. The other thing that we need to remind ourselves is reciprocal trig. So cosecant is the same thing as 1 over sine. Secant is the same thing as 1 over cosine. And cotangent is the same thing as cosine over sine, or 1 over tangent. A tangent being sine over cosine isn't a horrible thing to know either. So one of the things that comes up a lot with this is specifically our stuff about inverse. One of the things that comes up is the word arc. They used arc because when they didn't have access to exponents, they had to pick something else. So arc something just means the inverse. So arc tangent just means tangent inverse of x. Some people are arc people, some people are to the negative first power people. It doesn't really matter. We just need to be able to recognize both. So I'm going to show you guys how to find a derivative no matter what. But there are going to be faster ways. So find the derivative of sine inverse of x equals y. So the first thing we're going to do is, if we don't know the derivative of an inverse trig function, we need to get rid of it. So in order to get rid of an inverse trig function, I need to take the opposite version of whatever it is. So I have sine inverse here, so I need to take the sine of both sides. In doing so, what we have is something that looks like this. Sine of sine inverse goes away, so we just get x is equal to sine of y. So this is kind of a big thing because y is now our angle. So I have a triangle here. Our angle is y. I can go ahead and label my pieces here. So sine is the opposite over hypotenuse. So we have sine of y is equal to x, and because x can be written as a fraction, x divided by 1. So my opposite is x, and my hypotenuse is 1. If I need to, I can go ahead and solve for this third side. If I don't, then I don't need to. So let's solve for this third side really quick. So in order to solve for it, we need our Pythagorean theorem, a squared plus b squared equals c squared. C is always our hypotenuse, and it doesn't matter which one's a and b. So I'm going to say we have b is our opposite side. So a squared plus x squared equals 1 squared. We're going to move the x squared over, so a squared is equal to 1 minus x squared. And we just want a, not a squared, so a is equal to the square root of 1 minus x squared. We're not going to worry about negatives here right now. Our problem in itself will kind of take care of negatives. So we'll just kind of worry about this to begin with. So we have the square root of 1 minus x squared. Okay, so what we're going to do now is take the derivative of both sides. So we need to take the derivative. This requires us to be able to do implicit differentiation. So the derivative of x is 1. The derivative of sine is cosine of whatever's on the inside, y, times dy over dx. So now we want to get dy over dx by itself, so I'm going to divide both sides by cosine of y. So we have 1 over cosine y equals dy over dx. 1 over cosine is the same thing as secant, so secant of y is equal to dy over dx, but we don't want this in terms of y, we want it in terms of x. So cosine, or 1 over cosine, is just secant. Secant, because it's the reciprocal, we are just going to take adjacent over hypotenuse and flip it. So we're going to look at the hypotenuse divided by the adjacent. Our hypotenuse is 1, and our adjacent is 1, the square root of 1 minus x squared. So our final answer for this problem would be 1 divided by the square root of 1 minus x squared. This overall is not a horrible process to deal with when we are looking at our functions by itself. So it's normally okay when we have this. So let's look at a problem where it's going to be a little bit harder. So we have, find the derivative of y equals 5 times cosine inverse of x plus 3 plus 1. So we are going to do everything that we would to get rid of cosine inverse. In order to do that, we need to move the 1 over. So we have y minus 1 is equal to 5 times cosine inverse of x plus 3. We need to divide by 5. So y minus 1 divided by 5 of cosine inverse, or equals cosine inverse of x plus 3. And we need to take the cosine of both sides. This gives us cosine of y minus 1 over 5 equals x plus 3. So what this tells me is this is my angle. So I'm going to write y minus 1 over 5 in one of my angles. Okay, cosine is adjacent over hypotenuse. So my adjacent side is x plus 3, and my hypotenuse is 1. We're probably going to need this opposite side. So I have x plus 3 squared plus b squared equals 1 squared. I'm not going to work too hard, and I'm going to have to just subtract x plus 3 squared. So we have b squared equals 1 minus x plus 3 squared. Then I'm going to take a square root. So b is the square root of 1 minus x plus 3. So the square root of 1 minus x plus 3 squared, and that is our opposite side. Okay, so now we take our derivative. So the derivative of cosine is negative sine, and we keep our inside the same. Okay, we need to take the derivative of the inside. So y minus 1 divided by 5 is the same thing as saying y over 5 minus 1 over 5. The 1/5 is going to go away. Y divided by 5 is the same thing as saying 1/5 y, so we need to multiply this by our coefficient of 1/5. We also need to multiply this by dy over dx. The derivative of x plus 3 is 1. So now we're going to move stuff over. So I'm going to multiply both sides by 5. I'm going to divide both sides by negative sign, or just put the negative wherever. Doing so, we get dy over dx is equal to 5 divided by sine of y minus 1 over 5. Okay, sine is the same thing as opposite over hypotenuse. When it's in the denominator, we just flip it, so it's hypotenuse over opposite. So my hypotenuse is 1. My opposite is this lovely business over here. So our derivative is going to be negative 5 divided by the square root of 1 minus x plus 3 squared altogether. So when we're doing this, it's a lot easier to just know the formulas than to have to do this, because there are a lot of ways that we are going to be kind of messing up something that looks like this. So there are formulas that we are going to use instead. So the first one being sine. Sine of x is 1 over the square root of 1 minus x squared. Cosine is the exact same except for negative 1 over the square root of 1 minus x squared. Tangent, 1 over 1 plus x squared. And cotangent is exactly the same, where it is 1 over 1, negative 1 over 1 plus x squared. Secant and cosecant are kind of our bigger ones here. We have 1 over the absolute value of x times the square root of x squared minus 1, and the negative version of it. Okay, there is another way to look at this, which is with u's, and that has chain rule kind of put into it to begin with. So we're going to look at this problem that we just did, but we're going to look at it using the formula. So if I want to take the derivative of sine inverse, and if I want to do it with chain rule, one thing that I can think about is this. So sine inverse of u. So instead of an x squared, I have a u squared, so 1 over the square root of 1 minus u squared. But chain rule, we take the derivative of the outside and multiply by the derivative of the inside. So I'm going to multiply it by u prime. But I can also just write it as u prime divided by the square root of 1 minus u squared. This makes it so I just need to figure out what u is, figure out what the derivative is, and plug my stuff in. So we're going to use our formula to help us out here. So the derivative of 5 times cosine inverse of x plus 3 plus 1. So the really nice thing here is this plus 1, because it's a constant, goes away. So we really just need to deal with this. The first thing that we see is 5 times. So I know no matter what I'm doing, I'm going to be taking what I have, multiply it by 5. So now I need to do the derivative of cosine inverse of x plus 3. So I'm going to have the same thing as what I just wrote for sine, except it's now going to be cosine inverse of u. It's the same now. So we have negative 1 divided by the square root of 1 minus u squared. So let's start with this. So I have a negative 1 minus u squared. Well, u in our case is the stuff inside our parentheses, so all of this right here is u. So we have an x plus 3. And then in the numerator, we want to do the derivative of x plus 3. The derivative of x plus 3 happens to be 1. If I were to multiply those together, negative 5 over the square root of 1 minus x plus 3 squared, done. So knowing the formulas and knowing how to use them are going to be way more valuable than knowing how to do it from scratch. Knowing how to do it from scratch is more of like a backup tool to kind of help us out.